All right, thank you so much. So I'm going to go over to the slideshow, make sure that if this allows me to. Oh, no. All right, give me 1 second. You can't see anything, right? Oh, I feel so old. Why isn't this working? Okay, give me 1 second. I'll close it out.
Old, Jacob.
Not really. I'm sure there's people here that are older than me. Okay, give me a second. Your notifications blocked me from opening up the presentation, so thank you. Okay, well, it's totally not letting me do that, so I'm just going to do screen instead. Okay, so everybody can see this, right? All right, sweet. This is natural language processing with Microsoft Azure. So yeah, if you see me looking over here, I just got some notes. So pretty much I'll get started. The big picture of this is machine learning on Azure setup, practice some software. Definitely look at the Microsoft documentation if you have a lot of software experience or if you're like an older student and this is like too basic for you because it's going to be pretty big picture, how to set up with Azure, what is NLP, like what do the computers do in the background and all this stuff is happening. And so, yeah, I'm excited to go over it. Again, it's fairly big picture, should be accessible to freshmen or somebody as old as a senior. So yeah, let's get started. So real quick, make sure that you sign into our GM form because that's how you're going to get a great certificate that looks just like this. Pretty much you can stick this on your LinkedIn, put it on your resume, whatever you want, but it is an official Microsoft Learn certificate that you're only allowed to give out at events that are certified by the Student Ambassador Program, so you won't find it anywhere else. So totally, sign in, get your certificate if you follow along, and we'll send it to you directly. All right, so what is Microsoft Learn? That is the cringiest Bill Gates dabbing that I could find, but I'll explain what Learn is specifically. So it's pretty much a free platform that you can learn a bunch of different Microsoft services or just general data science and software engineering methods or things that you would ever like come across, and that there's different learning paths and modules that you can take to learn that specific skill. So it's pretty awesome. It's free. I definitely, I have to advocate for it, but I've used it before for a few things like brush up on data science or go over like a tech stack, and it's pretty helpful. It's really straightforward. It's fun and easy to follow along. And if you do a learning path, it's something like this where it gives you like what you'll learn, prerequisites, and then it will give you different modules how long it'll take with exercises and stuff. And it's pretty straightforward because a lot of it's on Azure, but it's different technologies, not just Microsoft. So definitely recommend it. Check out Microsoft Learn, and then I'll check out what is a student ambassador. So that is me wearing the same exact pullover, doing a rare dance because I don't actually, have fun ever. But that is during the internship. There's like this, I think it's this, this is like a K-pop dance challenge thing, and nobody else on my team was going to do it. So I did it. And you could find that video on YouTube somewhere, but I challenge you because it's going to be hard, but you will find it somewhere. It is somewhere, but this is a nice GIF from it, leading into what a student ambassador is. So pretty much you host events on whatever you want. You help bring knowledge and skills to your community, your campus. And for me, it's UT Austin. You can partner with other ambassadors locally, like within Texas and states, or like globally to do events. You get to collaborate with them through Microsoft Teams. You're kind of your campus link to all things Microsoft. So if y'all are interested in like, oh, I want to have a speaker series with somebody who works in this department at Microsoft, or I really want to hear what your mentor had to say from the internship and have them speak, just PM me, let me know, because I'd love to get those events organized for y'all for the Microsoft events that you want to see here on campus. That's pretty much the role of the student ambassador. Just a little context, I was an intern last summer doing software engineering, and I will be going back full-time when I graduate this spring. So if you have questions about the recruiting process, anything about Microsoft, just let me know. I'm here to help you out. So yeah, you can actually apply for the Student Ambassador Program, which you're about to see my Teams instance again, because I got to send some of those links. So if you want to apply to the program, wow, this is really not as, okay. Yeah, just check out this right here. There's an apply link that you can check out. And then also something else just to quickly look at is this form that I put out. It's a Microsoft form because, that's important to use. And on the Microsoft form, it's going to give you like, hey, 3 different things. If you're interested, let me know like what technologies you want to learn or any Microsoft questions you have, and fill that out, and I'll try to make that happen. So moving on, what is natural language processing? So pretty much it's an intersection of linguistics, computer science, and AI. And just to give like a little definition of what natural language is, it's something that's evolved naturally through humans through use and repetition, not something that's premeditated like a computer science language, but something that's just like spoken and it happens through generations. And the processing part is where the computer comes in. It's where you take the natural language and you process it in a way that computers can interpret it or do something useful with that information. So this is pretty much the interactions between computers and human language, and how a computer programs to process it and analyze a large amount of natural data is really what we're trying to focus on. So some of the use cases would be analyzing and interpreting text and documents, emails, or other sources, interpreting spoken languages and synthesize speech responses. You can see that on like Zoom transcript or like AutoGen YouTube closed captioning, which I think got killed recently, by the way. Interpreting commands and determining appropriate actions. And yeah, so there's a lot of different uses for NLP, but there's like a cool video that I want to show that kind of like gives a modern look at how does NLP look in terms of like a practical usage for like the gaming industry. So let me just pop that open if I can. Oh, actually, no, I'm sharing my screen. Easy, easy, perfect. You can see this? Wait, not easy. I'm not sharing my audio. It's okay. Okay, great, amazing, fantastic. Okay, is this working? Can you see that?
So think about this.
Yeah.
How often are you alive when the dawn of a new medium comes out? I knew that I had to be a part of VR because there are no rules.
Bruh.
The dawn of a new medium comes out. I knew that I had to be a part of VR because there are no rules for what Starship Commander is a choose your VR should be. Starship Commander is a choose your own adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out, how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want.
Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are going to talk. And these are the phrases that they're going to say.
Cool. What's my mission?
Must be something pretty important.
And then the second thing too was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements, and it's shockingly scary how good it picks up even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I've never seen an opportunity like this, where there's a wide open playing field. No one's written the rules yet. There's going to be tons of amazing software out there, and I just can't wait to see what other people write.
All right. Is everything back? Everything looks fine? Great. So yeah, that was natural language processing with VR. Definitely pretty exciting new front with both VR and NLP and just a bunch of different data science applications. So So yeah, I'll go into a little bit about, for NLP, this is really just, I want to say this is the tip of the iceberg, very big picture. If you want to learn a bit more about the specifics of like, how does data science actually work mathematically? How do you write these things from scratch without using services? Things like that. I definitely recommend plug for Data Science Lab and Principles in the ECE department. If you are in ECE, really good classes. I enjoyed them. Taking them together is definitely the move. So plan that out if you're interested in this type of stuff, if this kind of gets some cogs going in your head. So, and this particular workshop will be useful for hackathons, job interview and resumes, and something just really important to me, I think, is just a general understanding of some basic data science concepts, so you can kind of just understand when people are referencing to these things, or you're playing a game and you see something happen, or if you're watching a movie and you're like, how do they do that? You can kind of understand like, where is this coming from a big picture? And that's really a lot of the value of these shorter 1 hour events. It's not like, a lecture necessarily. It's not like doing a really long project, but it kind of gives you that intuition that is not exactly accessible from just, I guess, not looking at the content at all. So definitely useful for that type of stuff. So let's get started. So the agenda is just going to be going over text analytics, and then I'm going to talk about speech recognition, speech synthesis, setting up your Azure environment, and then we're going to do some interactive exercises to go over the topics covered with Azure. Okay, so what is text analytics? Pretty much, it sounds exactly, and it is exactly what it sounds like. It's just analyzing text for computers. And so this can get things like phrases or ideas out of the context of text, whether it's a document or a short paragraph or a text message. And if you think about people, we're pretty darn good at getting the context and name out of just a paragraph, right? If somebody gives you a book and they're like, read this excerpt and it mentions like Harry Potter, you immediately know, oh, this is from the Harry Potter franchise because I recognize the name. Or if you see context clues like wizards or like spells and you recognize some of those things, humans are pretty good at just making those relationships and connections, and that's something that really has not been present with computers for many years. And that's kind of where NLP is coming in and how we're using machine learning to make those things happen with computers. And so because humans rely on experiences and background and insight, you're probably wondering, how do computers do that? How do they process that where it relies on past knowledge? And so I'll give you like a very basic answer. There's a few different ways that computers can do this process to make it easier for them to process. So the first example is something like stop words. So this is like statistical analysis of your words. So if you're going through the word and you see something like the or to, those are normally stop words that if you took them out of your paragraph, it wouldn't change the meaning at all. It'd sound exactly the same if you just took out all those does and whatever, all the semantics, even though it doesn't come across as proper English. You know what the content of the word is, and you know what the paragraph's trying to say, even though you don't have those stop words. So pruning those out up front is kind of like the first step of what a process of natural language processing could be for text analytics. So the next step would be something like a frequency analysis. And that sounds like, complicated, but it's really not. Because if you think about, what is frequency, it's just how often something appears. So if you look at a paragraph and you're trying to like analyze it, and you group together like words that have to do with wizards, right? Words that have to do with magic, and you group those together on how many times they're mentioned, you can kind of give a skew of, oh, it's more about this topic than this topic based on the recurrence of these types of words. And something to deal with like multi-term phrases like hyphens or dashes is something called n-gramming, where you take together multiple separate ideas, so it doesn't have to be a word, and then you can like group them together in an n-gram, where n is just the representation of how many different ideas are covered within that. So two different ideas would be a bigram, and then that's why it's called n-gram, because it could be as many different lengths as it needs to be. So a third example is stemming, or lemmatization. So these two things is like grouping together similar words and be interpreted by the computer as the same word. So if I had something like power or powerful or powered, those could be all interpreted by the computer in terms of contextual understanding as one word. So you just kind of group those together and then it'll interpret it in that way. So that's one other technique. And next one is encoding. So this is another way, computers are really good with vectors. They're really good with matrices. That's why we have GPUs in general, which is a bunch of matrix calculations. And so if we can take a paragraph, like a natural language, and turn it into something that is understandable by computers down to like a matrix level, that often helps with a lot of the more in-depth and more difficult computation down the line. So an easy example is something that I'm showing right here on the right, which is one-hot encoding. So this is taking different words and it's saying 1 if it's in the paragraph and 0 if it's not. And in terms of like how you use this after you encode it, I'm not going to go too much in detail, but that is a technique that is definitely out there for a lot of different NLP applications. And it's a good gateway just to be familiar that one-hot encoding is totally a thing. So the next one is vectorization. So this is taking the relationship between different words and putting it in a vector. So let's say you have plants and you have flowers. If you have a vector that's of n length, plants and flowers would be closer between each other if you're using vectorization than something like skateboard or video games. So then the distance between these two entities would kind of dictate how much they're related together. And so those are some just like very basic, broad ideas. And if you're interested in any of these in the way it sounds, I definitely recommend looking up more, complex things and like looking in depth at these techniques, because there's some really cool math behind it. And again, plug for those data science classes in ACE. But that's just like an introduction of like, what could be going on. So the next question is, how do we do this in Azure? And why Azure? Why specifically? Why are these things like Azure or AWS or all these other machine learning services out there? You're probably wondering, can't we just write it yourself, right? And you can write models yourself, and you can use something like Python packages like sklearn or sklearn or things like that. And those are all great, but using services is a very realistic thing that you're going to do in the industry or personal projects or hackathons or things where you need something that works properly and it's running in a very containerized and tested instance. So if you have a machine learning model on Azure that you're using, you can do all of your advanced sentiment analysis or all your advanced machine learning on that platform without having to do it all from scratch and not having to reinvent the wheel. And that's kind of the purpose of some of these more enterprise grade machine learning services, something like Azure, which is much more than a machine learning service. But for example, why you'd want to use that, it's just because it's convenient, it's easy, it's tested, and it works. And that's why like games out there, a lot of games use Azure, they use AWS, they use Google Cloud Platform. These are not something that you use because you don't necessarily know it. It's using it because it makes sense to use it in that context. And so that's kind of why, why Azure in the first place. And it'll be very helpful, I think, just to know, because a lot of services are kind of based off of the way Azure structures itself. So I'll go into like for NLP specifically, the things that Azure does for text analytics is it can determine the language of a document. And I'll go into like what that looks like in practicality. It can give you the sentiment of the document, more positive, more negative. It can extract key phrases from the text, which is super useful for a lot of different use cases. And then also it can identify and categorize entities in the text. And so entities are just things like people, places, organizations, everyday items, times, anything like that, quantities. And it can identify them as recognizable entities, put it in take it out of the document and just be like, okay, these are the entities that are in this paragraph. So if I have a paragraph that has something like Bill Gates in it, it'll remove it and be like, this is my entity. Like, there is an entity of Bill Gates in this paragraph. And the other cool thing it does is automatically, if you wanted to, give a link to a Wikipedia article for that entity. So you can already think like there's a lot of ways that you can apply this to your own personal projects in ways that are really cool. And if part of it is like associated with Wikipedia or finding out more information about it after finding those entities, that's totally up to you. So examples of when we see this apply in real world applications, one of them would be like a social media feed analyzer, like analyzing Twitter or sentiment analysis over time, depending on like when certain people do things, did the sentiment go up and down? Document search, an application that extracts key phrases. I think there's a lot of services already out there. Or if you think about like a tool to extract brand information or company names from a document or text, I'm sure a lot of legal services use those things. So there's a lot of application for this text analytics in Azure. So this is an example of language detection. So if you look at the first review, it has an English statement. The second one's clearly Spanish, and the third one is actually an English sentence using some French words. So if you look at the bottom of what it returns when you run the language detection, it'll give you the language name. It'll give you the ISO 3691 code, and that's pretty much just like, look at it, ES, EN. You've seen those before. It's just like an identifying code for different languages, and it'll also give you the score between 0 to 1. So that score is probably the most confusing part of this, and it's not really that confusing. It's just telling you how certain is the model that you're running on Azure, is it that it's that language? So if it's English and it knows it's English, it's going to give you a score of 1. But if you look at the third column, it doesn't really know it's 100% English because there are some French words in there, but it's pretty confident that it's actually structured in a way and it has words that are joined in a way that make it English. And that's why it's giving a pretty confident score that this is actually an English statement. So you can see it's pretty good because even though it's starting with, it has a bunch of French words in there, it's not just comparing how many French words, it's looking at the structure of it. It's looking at the placement of like the different parts of speech, and that's why it's giving you that score. And so when you have like an ambiguous or like a mixed language content, it'll try to give you a score and focus on the majority of the language in that text based off of structure and content. So yeah. And this is the sentiment analysis. This is what it kind of looks like if you have an example of a high sentiment, which is going to be closer to 1. That's the first paragraph, right? It looks like a lot of positive words in there. It looks like friendly, you know, right away, table is clean. That's a score about 0.9 if you're to run this on the Azure service. And the one at the bottom, very negative experience. It's talking about the worst experience ever. Food is awful, all that stuff. It gives you a sentiment score of 0.1. And so now you can start to think, right? If I really wanted to make an application that is like worst reviews ever, instead of going through each review ever for a use case, I could just like import, you know, find data online from an API, like find a service, take in all those reviews, and establish a sentiment using these services on Azure. And if it's like below 0.2, right, it's a really bad review, then I just shoot it on my website. And that'd be a really quick way to solve certain problems based on what you want. And if you're looking for like neutral things, you just kind of keep a range between, I don't know, 0.45 to 0.56 or something like 0.55, something like that, right? So you can do a lot with that score, which is, you know, how certain are we that it's more positive or more negative, which is really cool. And it's a lot better than just giving you a binary 1 or 0 because you can get those more extremes or those neutrals, and if you want to extract that out. So yeah, so the next thing is key phrase extraction. This one's pretty straightforward. It's just looking at your text and extracting like the key phrases. And this is pretty much just looking, you know, what are some conjunction words, what are some stop words, what are things that we could just prune out and they don't really have anything to do with what it's trying to say. And that's pretty nice. It works pretty well. And again, there's a lot of different ways that you can use this. So let's say you're making like an interview bot, and you're trying to take the key points out of like a response, and it just gives you what are the key things that they said. You could use that on both the recruiting end, on both the hiring and the recruiter side or recruitee side. Okay, so this is the entity recognition that I was talking about, where it takes the entity on the left and it gives you like the type. So if you see it, let's say I had a text, right? It said like Bill Gates something, John said something, Paris, New York, right? Some sort of sentences that all string together. Doesn't matter how long the document is. It'll give you the type of the entity. It'll give you the subtype if they know it, if it exists. And then it'll give you at the bottom, it can give you like the Wikipedia article. And so if you're wondering like how would this actually look in practice, it'll look literally just like this. It'll be a matrix, or it'll be a list, or like a more complex data structure that looks like a table in your head, and like it can access it just like a table. So you can like extract the type, the subtype, the example, and do all that manipulation that you're used to for arrays. And that's what it's returning. Okay, so just make sure I'm not speaking to nothing. Can somebody please just say that they can properly hear me, because I get this paranoid thing that nobody can hear me. But
can hear you. Yes.
Okay.
Yeah, we can hear you.
I greatly appreciate it, because I was thinking, you know, I can't see the chat. So what if I am just talking to nobody and you're like frantically texting me, Jacob, you're just talking to nobody. Anyway, that's probably like a bad dream. Anyway, speech recognition. So before we go, a little meme, but not a meme. It's that you're gonna have to know what a phoneme is, and that's because I'm gonna use it twice in this. It's pretty much, yeah, any distinct sound of a specified language distinguishes one word from another. So in this example, pad, pat, bad, bat, right? You know, going back to basic grammar. So phoneme, it's just distinct sound that distinguishes stuff. All right, that's all it is. Okay, so what is speech recognition? Well, you've probably already used it before, and the only reason Cortana's there is because, you know, I have to, contractually, right? But Siri, Google Home, Amazon Echo Dots, CarPlay, Android Auto, you've used these before, right? Voice recognition, like, hey Siri, do something, or turn off the lights, or, whatever, check the time. That's stuff they use all the time, and they're using natural language processing. And if it's on Amazon or if it's on Google, you can bet that they're using the Google and Amazon services. And I can promise you that Cortana is using some form of the Microsoft services. But you can see like there's plenty of third-party use cases for these open source or like open accessible or like paid subscription services where other companies can pay for these software giants to use like all your services that you're using and collected in these models and make these things happen and work for your own thing. So that's why, knowing this stuff is important. Let's say you want to make a game one day, or if you want to make an app one day and use these services, they will be there for you to make some really cool stuff without you having to know all the specifics in the maths to make like a machine learning model, which is, just making the playing field easier for a lot of people to access and make machine learning more accessible to everybody. But, obviously there's more like ethics stuff and all that stuff, but I'm not going to go into that. Anyway, so yeah, this is speech recognition, what these look like. Okay. So how do computers usually do this? Okay, so this is pretty much what it's doing is it's going to be transcribing speech to text most often. And you can see that in all of your Zoom classes. If you click on the like the transcription, it'll give you like some response of what they're saying. And if you look at some articles, there's stuff like Zoom AI, right? Zoom AI, and you're going to hear a lot of that where people say, AI this, AI that, AI is taking over the world. Not yet, right? One thing I'll say, that's maybe just an opinion, but what I'm saying is AI is used so often by so many people for so many different things, but a lot of the times it can be pretty, not basic, but it's pretty like straightforward one case use scenario for this one AI application to use for one specific thing to give us this one thing. It's not like all AI is connected to the one big, huge thing that's doing everything, right? In this example for Zoom, it's just they're using an AI NLP service to translate what he's saying and putting it out into some sort of text for you to view. And so you might be seeing that buzzword, Zoom AI or these AI. But then I guess the next question to ask yourself is like, what type of AI are they using? Because there's a lot of different AI out there. And NLP is just like one relatively simple example in comparison to some of the more advanced AI techniques. So, just wanted to like give that quick contextual intuition. So yeah, they're using AI to create this NLP service to create that output. And so what a computer usually does is it can transcribe either live things or recorded file inputs. And I think in the demo today, we're going to do a file input where it takes that, whatever they're saying, and then transcribes it to texts. And the way it does that is it's analyzing speech patterns to determine recognizable patterns that are mapped to some sort of word. So once it finds those patterns, maps it over, using like maybe some sort of map data structure, maps it to words. And then what it does is there's like two different primary ways, two different types of models. Either there's an acoustic model or there's a language model. So an acoustic model converts audio signals into phonemes, there's the word, which is just representations of specific sounds. So the audio signal becomes a phoneme, that's what it's converting it to. And then the language model maps the phonemes to words using a statistical algorithm that predicts the most probable sequence of words based on the phonemes. Now it sounds pretty complicated, but like in simple ways, let's say I'm saying like, a recognizable, right? Recognizable. If I say recog, there's only an X amount of words that'll come after that. And if you have a model that can start predicting that, oh, they're going to say recognizable, then you're more easily able to translate what they're saying into actual text and do it like on the fly. And that's why if you see like on Siri, when you're speaking into your phone, sometimes based on the context of the word, it'll change like the add-on word to it, right? Like it'll like the grammar to make it right, because it knows based off of what you're saying and the phonemes that you're creating, what is the proper sequence to be going there. And that's pretty cool. And those are some pretty advanced NLP structures there. So other examples of how you could use this is like closed captioning in YouTube. We have the Zoom thing here, automated note dictation, which is on Siri, determining intended user input, which we saw with the Starship Commander. So there's a lot of uses for this exact application. Okay, speech synthesis. So this is the opposite of speech recognition. This is creating speech, which is like, I don't know if you've seen, what is it, Space Odyssey 2001, but HAL 9000, right? HAL 9000 is using speech synthesis. He, it, she, I don't know. It is HAL. HAL is creating speech from computer code, right? And it's masking in some sort of voice, which is like this ominous voice. to create some sort of output. And on Siri, you know, there's the opposite. They listen to you, but Siri also talks back to you. And if you listen in the past, I think 5 or 6 years, Siri's actually becomes a lot better sounding. She doesn't sound nearly as choppy. She sounds more smooth. She sounds more natural. And the way that they're doing that is natural language processing using neural networks. But I'm not going to go into that. But that is what they're doing. They're using neural networks to make it sound better. And look up what that stuff is if you've never heard it before. If you have, you're probably like, oh, that's cool, right? Okay, so what is it? So if you go on your Microsoft settings and you go to your voices for the accessibility options, you can choose a voice and you can choose like Microsoft David, which is like that classic sound, you know, sorry, this has really nothing to do with it, but that's pretty much, you know, this is a speech synthesis example. Microsoft David is some speech synthesis. Okay, so how does this one work? It's a little bit different. So it usually texts, so it breaks down individual words. So in your, you know, let's say you have your block of text, it'll break down it to individual words, assign phonetic sounds to each word, and then it breaks down the phonetic transcript into like units of phrases, clause, or sentences to create phonemes that'll be converted to audio, right? So it's just ways that you can tokenize it, breaking it down, make it into units, and then shooting out to audio. Again, very big picture, but that is what's happening. So then the phonemes are synthesized as audio by applying some sort of voice. So, you know, like on Siri, you have a certain voice, you can change voice settings, and all that does is it's doing some signal processing to determine like the parameters of like the pitch or the timbre, or, you know, how do you want it to sound? And that's at that point, it's beyond like the actual NLP steps and more into signal processing. So at that point, you have an audio waveform that can be converted, you know, shot on output on a speaker or written to a file and played later. You know, there's different ways you can do once you've done that breakdown. So yeah, so like the use case for this stuff is generating spoken response to user input, which we've seen with Siri, creating voice menus for phones, which you've seen in the 1990s, reading emails or text messages and hands-free scenarios. Oh man, that's like Duo. If you haven't set up your Duo like authentication, you know, it's like call me if you are too lazy to fix that, which is totally not me. Okay, broadcasting announcements and publications. I'm sure you've heard that at school, buses, you know, your number, that type of stuff. Accessibility. Accessibility is huge, right? Being able to hear things if you can't see is, you know, how else are you going to be able to use your phone? And as we get more advanced as a society, NLP will probably become more and more important for accessibility things as we expand to different, I think it's called edge device AI, where it's like all things are using like machine learning, or all things are connected to the internet at some point. And if all things can talk to you and give you like audio things, that can really help accessibility in the future. So yeah, there's a lot going on with this stuff. It's really cool. I think it's really neat. So now we're going to go into setting up your Microsoft Azure environment. So at this point, we're doing a little bit of a pivot from the theory stuff and like, you know, a little bit of the introduction to what it is and to how to do it on Microsoft Azure. So yes, that's a pretty beefy setup. It should not be too bad, I think. Okay, so yes, if you didn't get that Azure.com free students, please go there right now. Activate your $100. It's really cheap. I mean, it's free. It's a lot of money for free stuff because you're a student. If you graduate, you can't do this anymore, right? It's free. It doesn't require a credit card. Go ahead and do that. Okay, so now the machine learning workspace. Now this is going to get kind of messy. So I am sharing my screen, right? So you can see this screen, right? Everybody? Just one person.
Yeah.
Okay, sweet. Thank you. I don't know who that was, but I sincerely appreciate that. Okay, so I'm going to close out. Actually, no, this is important. So I'm going to go into the, Okay, yeah, so pretty much go to your Azure portal, which is portal.azure.com. I'm going to try to send that over in the Teams. I hope this doesn't look gosh awful. Yeah, so this is portal.azure.com. This is your Azure portal, which will be able to set up your physical environment. Okay, so once you're there, then you go to Azure Services and you create a resource just by clicking that nice big check. And then you just search for machine learning, and then you go to machine learning create. So this is creating a machine learning resource inside of your Azure environment. So big picture, Azure has like different resources that you can use for different scenarios. So let's say you want to set up a database, right? You can make an SQL database. If you don't know what SQL does, you know, all it is just like it's a tabular-based database. A tabular-based database on your Azure service, and if you want to make some sort of machine learning process, you make your little machine learning process and then link it up to something else. I think you kind of get the picture. It's like little pieces of the puzzle to build a full service or full application or whatever you're trying to build on Azure. So that's why you need to make a machine learning resource. So that's creating your workspace. So when you're creating it, it's going to have like your workspace name. Just put a unique name, whatever. Subscription. So it's going to have the option to just select like your Azure subscription for students, your group. Just put any unique name, and then location. I think it should like automatically have a location. So just put that in, and then we should be good to go. It's going to take I think a couple minutes to get started, but I think by the time we get to the exercises, hopefully we have time. Yeah, 17 minutes. Yeah, it should be fine. Okay. So then you go over to the top left of your computer and click on the All Resources button, which will take you to your different resources. And at this point, you should have like a little, I think that's I think beaker. Yes, it's a little beaker with a made out of Azure logo. Okay, yeah. So whatever you called it, just click on that, and it'll take you to your machine learning little resource that you can click on. So click on the overview, and then once you're on the overview, click on the link to your resource. And so at that point, it should look like this. So if I was going to my resources, okay, yeah, this is it. That's not it. Yeah, overview. So then this is Studio Web URL. I clicked it. It'll take me here, which is my actual physical resource, and I'll get to what to do next in just a second. So at that point, you're on your resource. So then you're going to need to make a compute instance. So this is just something, and if you're thinking, what the heck, we just made a machine learning resource. What is a compute resource? That's what I thought the very first time I saw this. But then I understand, it's like a computer that's running on Azure, but it's your own little computer. And that's literally what it is. You're creating your own little computer. And that's why it costs, you can get like $300 Azure credits. So pretty much it's like your money or like that free money translates to the amount of time you can use their computer at their service area for how long. And so these are the recommended settings. You go to Home, you create a new compute instance under, you just hit Create New, and then you go to Compute, and then Compute Instance, and you hit New. So once you create a new one, you could just, whatever name you want, region, East, US, CPU, you just click CPU, not GPU. The difference is, if you're not familiar, CPU is like your central processing unit. That's like all of your threads and a lot of the, decisions are on there. And then I guess they're both decisions, but like GPU is your graphics processing unit, which is a lot more heavy duty, like matrix calculations. And both have their pros and cons for different things. Some programs are more CPU intensive, some more GPU intensive. But pretty much in this case, since we're not doing like any massive amounts of data processing on our notebook, we're going to want to be using CPU. And then for the virtual machine size, just pick this one. It's a nice one, 14 gigs of RAM. I think it's one of the cheaper ones, or it doesn't really matter since you have the free credits. Okay, so once you create your compute instance, then you're going to make a cognitive service. Okay, so this one, go back to the portal.azure.com, and this is the same way that you made a machine learning resource, except you're creating a cognitive service resource. So you hit the plus again, create a resource, you go to cognitive services, and then you put in these parameters. Any name, your subscription, same thing, any available location, and then pricing tier, just do S0, and then any resource group. I think if you already have one, you can just put in the same one. Should not make a big difference there. So at that point, you should have your cognitive service running, your machine learning service running, and everything should look pretty good on your side of it. So just for give an example, this is Microsoft Azure. So if I go to my all resources, right, I have my egg cog, which is my cognitive service, and that's what that is. So, and then you have your learn NLP, and this is my machine learning service. So they're both right here, and everything's just sitting right. Everything looks good. So yeah, and if you're not following now, like don't worry, this will be recorded, so you can always like come back and check it out if you're interested in finishing it up. All right, so cognitive service. So this is just something, get this on hand. So when you're into your cognitive service, just go to the overview, and then once you're at overview, you see that little link right here. It says click here to manage keys. Click on that, keep that open in a separate tab. You're going to need those keys in a second, because we're going to need that to link to your service once we get to the things that use the cognitive service. So that shouldn't take too long. Just pull up that, click on an overview, manage keys, and then at that point you should have everything ready to go to do some fun exercises. So yeah, I hope somebody is following right now. That'd be cool. But if not, again, totally understandable. Hard to do within the hour. But yeah, let's go over the exercises. So I'll just do it on my screen. I'll talk over a little bit about what's going on in the code. I'm not going to go too much in depth just because I know there's different skill and experience levels here. But I'll just kind of go over, and it gives you some nice explanation. So yeah, wait, actually, sorry, I'm done. There's one more step, which is if you go to, yes, one more step, interactive exercises. So yeah, sorry about this. So last thing is that you have to get the files, right? So this one's pretty fun. If you're familiar with Python, you can have Python notebooks inside of Azure, like Azure Machine Learning, your little resource, independently. So you don't have to use your console. You don't have to use any of your own Python or anything like that. All of it's running on Azure on your little instance. So you don't have to worry about anything. It's all contained inside of there. So all you have to do is go over to your sidebar. You click on your compute inside of your, no, not your compute. You click on notebooks inside of your Azure Machine Learning. So then you create in your file location, uses your name. I think that's default. You call the file whatever you want. I think get files is what was recommended because that's what we're going to be doing with this notebook. File type notebook. All a notebook is some way that you can run Python in a very easy way. So it pretty much creates cells in your Python file so you can run those cells independently. So let's say I have one cell to declare some variables and I do some declarations. I run that cell, and then in a separate cell, I do some processing with those variables. I run that cell. So if I don't want to have them all running at once, if I want to do them sequentially for some reason or another, that is why you use notebooks. It's really good for testing, but it's also really good for data science and data analytics because you can run things independently and then you can do commentary afterwards in between. So if you ever take data science lab or principles, you'll be very familiar with using notebooks. Or I think if you take in matrices with Professor Gilbert, he goes over some Python stuff with notebooks. So notebooks, totally cool. You can do it on Azure in the compute instance or in the notebooks instance on your thing. So override if it already exists, and then you can see it running. So the last thing that you need to do is go to your first cell inside of your notebook and then run this command. So I'll send what command you need to run. Run this command inside of your very first thing. So that is going to, don't go to the link. The whole command is right there. So you got to do the exclamation point, git clone, and then do that link. And all that's going to do is it's going to clone in your these AI fundamental workshop type files inside of your workspace. So in my notebooks, you can see right here, Azure Machine Learning Studio, notebooks, get files. I made the thing, git clone, and there it is. You just run it, and it'll clone the, yeah, it already exists, so it's not going to do it. But if it does not exist, which it shouldn't, you just run this, and all this does is it adds this folder to your directory. If you're not familiar with Git, again, all it is it's taking code from someplace on the internet, GitHub, on their repository, and it's copying it to your local area. In this case, it's on Azure. And then you just hit the refresh button, and it'll give you a nice folder which contains all the AI fundamentals. And there's quite a few cool exercises here if you want to go over them, but and you can do these in your own time. That's kind of the fun thing, but I'll be going over the two that we covered today, which is the text analytics and the speech. All the other ones, you can do that if you want in your own time. And so give me 1 second. Okay, yeah, so let's do the text analytics one. Okay, so it'll give you some nice description. I'm not going to read all that stuff. You don't really need to. Yeah, you can in your own time. It's not too much information that we haven't already covered. So pretty much all we're doing here, if I run this cell, this is giving me some reviews of a hotel listing, and it's just listing them out with all of the name of the review and then what the review is saying. So this is just a basic example. Let's say you're running a hotel and then you collect data in some way and it's formatted this way, and you just want to print it out. That's what this first cell is doing before we do any of the text analytics. And if you just want to follow briefly, I'll just kind of vaguely go over what's going on here. So it's just creating a variable that's going to the path.join. So if you go to data, which is under data, and then if you go to text and then reviews, you can see there's a folder with reviews. So all this is doing is it's taking out the whole folder right here to create some sort of, entity that contains the folder of reviews. So then we're creating a collection, which is like similar to an array, except it has some key value pair matching, and that's what's happening here. So we're just iterating through our reviews in that folder, and then we're assigning a variable called review text, which is pretty much just, if you look at this, like open OS path, that stuff doesn't really matter. But what's happening is, well, it does matter, but it's not, you know, whatever. What I'm saying is, it's opening up inside of the reviews folder, and then the file name, it's opening up that file. So because we're iterating by file name, it's going to iterate at review 1, review 2, review 3, review 4. So it'll take the file name in that folder, and then it'll read that data. So it'll take the text that's in there and then assign it to the review text. So that's the actual text that's inside of the review, which is, you know, this stuff, all that stuff. And then the review, what they're going to do is we're going to create a collection, which assigns inside of that collection, each entity in the collection has an ID with the file name, which is going to be like review 1, review 2, 3, 4, and then the text, which is the key, which is the view text. So it's going to be this stuff. So then you'll have an object that has both this and all this stuff keyed in by these keys, and then it's just appending it. So then that's all that's doing. And if you're wondering like what the heck this stuff is, this is just a Python placeholder, these curly braces, for formatting. So it's going to print out whatever's in here. So this, it's just pretty much this gets put here, and this stuff gets put there, and then you new line between them. And that's why you have that stuff. So if you remove this new line, you'd see that the new line between the text stuff is now gone. So that's all that's doing. That's what that placeholder is. And then, pretty straightforward. We have our stuff. And if this stuff, if you've, let's say your first year and you haven't taken anything with functions or anything with for loops and stuff, please don't get scared away from this. I remember my freshman year, if I saw this, I'd probably be like, different levels of experience for different people. I think some of y'all will be like, oh, this is straightforward. Some of y'all, won't have seen this before, but that's totally okay. And I think it's great just to get some exposure of what's going on without actually understanding everything. And that's totally fine. But if you do get it, awesome. I think there's plenty of upperclassmen here. So this is what this is doing is, how I said, get your cognitive service set up. There's a cognitive service key and there's an endpoint. On that keys document, there are two keys. You take key 1 and you put it here, and then you take the endpoint and you put it right there. And it's just giving you the stuff. This print line is just a fancy way to say we have our keys, it's in the document, it's in some sort of variable. The next thing that we're doing is pip install. And so all this is doing is it's installing this package to our local instance of this notebook. And again, if you don't know what that means, all it is it's like there's some sort of like code that's written out there that we need to use, which in this case is the Azure Cognitive Services language text analytics, that we need to use stuff from that, which you'll see here. We're going to be using import it from, we need it there. So it needs to be downloaded to our local instance of this Python notebook in order to use it. So in this case, I already ran it, it's already on here, so it's here. So just run that line. And then this is where we're actually going to be using some of the text analytics. And for the sake of time, I'm not going to go into like the specifics of all the Python, like what's happening here, but I'll just run it so you can see what's going on. So for each review, you can see it's giving you like English or like the code or the score, how confident it's English. All of these are English. That's pretty cool. The next thing is like extracting key phrases. When we run it, it's I think I added that, my bad. So when you're running it, it's pulling out each of the key phrase per review documents. So this is just giving you an idea of, how does this actually look in person when you're running this stuff. And again, this stuff is on hackathons. If you get this set up on your pipeline up front, this can really help you out and get like some nice stuff. But anyway, so sentiment analysis, yeah, I've used like Microsoft Cognitive Services before for my hackathons. Definitely help you out. Anyway, so positive, this one, it tells you the sentiment. This one is super negative, right? That's e to the -7. That is so negative. I don't even know what that one says. This one's super negative too, but these are pretty positive, right? They're almost 1. So yeah, and like, for example, yeah, you can actually, doesn't matter, but you can like add that sentiment to one of the fields in your collection to like tie it to that whole review. But I'm not going to show that here. So extract known entities, this is what we were talking about. You can pull out like all of the entities that are in there. I think, oh yeah, I removed an if statement. So I think this is just saying the entity has to be a date and time or a location, which in this case you'll see, locations, Royal Hotel, London, all this stuff. Give you a Wikipedia article like I was talking about. That's what it looks like. That's pretty cool stuff. So the next one that I'm going to go over, which is the speech analytics, or I think it's just speech, the speech part. Yeah, so this one is going to be pretty straightforward. I think it's shorter than the last one, and what it's doing is you're getting your same cog key and endpoint. You're setting that up, same thing as before, same cognitive services. You don't need two of them. You're doing a pip install, but you're doing it instead for cognitive services.speech instead of for the text analytics. And then
turn the light on.
Yeah, you hear that? Wait, can you actually hear that or no?
Yeah, we heard it.
Okay, great.
Turn the light on.
Yeah, so this is what it kind of sounds like. You can make it sound like somebody else, but this is just setting up your speech configuration, and then you're giving it a WAV file to put in to translate that to audio. So this should be
turn the light off.
Yeah, so like if I record myself, I could just say whatever and then send it through. We could take the audio from this and then we'll give you a transcript. Or even, you can set this up to make it a live microphone thing to give you what it's saying as it's going. It's a little bit more complicated than this implementation, but if you check out the documentation for this stuff, it is not too difficult to set that up. So, all right.
Turning the light on.
Okay, so this one, speech synthesis, because I don't have a whole lot of time, I'll just actually... I added a tiny bit to this to change it, barely, to make it a little bit better.
Jacob woke.
Ah, it should be random.
Pranesh lurking.
So pretty much, you can see what it's doing, right?
Rithvik, contemplate.
Yeah, these are some of the officers. It's giving like a random...
Mohit, smiling.
Oh, bet. Okay, yeah, so all this is doing is it's taking the name of the file and it's reading it to you. It's synthesizing it. And then it's going through and finding like a bunch of pictures that I put in to the file. Yeah, here it is. Here's the folder that it's looking for. So, and these are the file names. So it's just, all my memes should be here. It's getting a random index, and then it's putting it out, and it's saying the name of the file and associating the file and displaying it as well. So these are like some very basic exercises, very basic stuff about these. Definitely check these out again on your own time and look at the other exercises if you're interested, or like try and understand some of the complexities of the code. But other than that, I think that's it. Thank you all so much. I hope you enjoyed. I hope you learned something from this event. Yeah, thank you. Thank you for coming. You'll get your certificate in your mailbox. Yeah, not physical mailbox. Gmail. Outlook. I don't know.
Amazing. Thank you,
All right.
Jacob.
Thanks, Jacob.
Yeah, no worries.